Particle accelerators contribute to advances in medicine, industry, and security. But it is in the field of high-energy physics where physicists use particle accelerators to develop a profound understanding of the fundamental particles and laws that govern matter, energy, space, and time. Led by Barry Barish, between 2007 and 2013, more than 1,000 scientists from around the world collaborated in a global design effort for the International Linear Collider, or ILC. Consisting of two linear accelerators, or LINACs, the ILC will deepen mankind's understanding of matter by accelerating and colliding electrons and their antiparticles, positrons. What enables these particles to accelerate to incredible speeds is the use of superconducting radio frequency cavities, or SRF. The SRF cavities are made of highly polished niobium and can create 14 million volts within the SRF while generating only 30 watts of heat. To reliably perform in this fashion, the SRF cavities must be highly polished to remove all imperfections. Historically, this has been accomplished using an electropolishing, or EP process for surface finishing that is conducted in a 1-part hydrofluoric to 9 parts sulfuric acid mixture. Hydrofluoric acid, or HF, does not behave like other acids. Upon contact, HF is absorbed into the skin and body, destroying everything in its path. Large HF exposure always leads to death, even with first aid or medical treatment, and rarely have people survived with greater than 8% of body exposure. There has been a long-felt need for a simpler, more environmentally friendly green EP process for niobium SRF cavities. Now, for several years, Faraday Technology, Inc., an innovative small business located in Englewood, Ohio, has worked closely with the DOE's Thomas Jefferson Lab, Fermi Lab, and Advanced Energy Systems in order to develop and demonstrate an alternative to the use of hydrofluoric acid for surface polishing. This revolutionary method, which uses pulse reverse or bipolar current instead of direct current, is referred to as the Faradayik HF-free EP process. It reliably meets the performance requirements for the surface polishing of the SRF niobium cavities, but does so in a benign fashion. Based on pulse reverse electrolysis, this method has demonstrated success from coupons to cavities using low concentration sulfuric acid water solutions without hydrofluoric acid. The result is a new paradigm which leaves behind the Jacquet models of the 1930s based on concentrated acids. The Faradayik HF-free EP process represents a dramatic new process for EP in general and niobium in particular. The scalability and reduced cost of bipolar EP relative to standard horizontal electropolishing with cavity rotation holds the promise of providing a significant boost to industrialization of SRF cavity surface finishing and an important step towards the industrialization of niobium SRF cavity EP for the International Linear Collider.